So let's practice one of these. Let's practice our new theorem. So given this regular hexagon on the right, we're actually going to find the sum of the interior angles, which again means that the sum of the interior angles means all 6 angles, 1, 2, 3, 4, 5, 6, added up. So if you forget the formula, we can look at it as a series of triangles. So 1, 2, 1, 2, 3, 4 different triangles. Or using the formula, we have 6 shapes, or 6 sides, minus 2 times 180. This gives us 720 degrees. So the sum of the interior angles, and we're going to use a math expression really quick, the sum, the interior angles, equals 720 degrees. Now this little e is called sigma in Greek. It means the sum of, all of the sides added up, or all the sum of. Now to find the measure of an interior angle, that's actually very simple. Because all of the interior angles are the same measure, we're essentially just going to take the sum of the interior angles and we're actually just going to divide that by n, the number of sides, and that is actually equal to an interior angle. So this shouldn't be too bad. We're going to find the sum of the interior angles, and because they're all the same measure, we could just divide by how many sides, in this case it's 6, and find out what that is. So the sum of the interior angles is 720. And we're going to divide that by 6 sides. That should give us 120 degrees per angle. So let's take that and use it on the next problem. So the polygon exterior angle sum theorem is another easy one. So really notice it's all based on the foundational piece that we did in the beginning. So we have this regular hexagon again. We know that the sum of the interior angle, let's move our sum back over. The sum of the interior angles is equal to 720 degrees. We know an interior angle equals 120 degrees. So let's think about it for a sec. If this is 120 degrees, and we start to look at angle 7, which is supplementary to it, then couldn't we say that angle 7 equals 60 degrees? But if that's the case for angle 7, and angle 2 is also 120 degrees, then I believe that means that angle 8 is also 60 degrees. So we have angle 7 equals 60. Angle 8 equals 60. Essentially, all of the angles are equal to 60 degrees. So one way we could actually solve this in a much faster way, using the exterior angle theorem. Exterior angle theorem is in the following manner. We take the number of sides, so n, and we're just going to divide by 360 degrees. And when we divide that by, oh, I'm sorry, that's backwards. We take 360 degrees and we divide that by n. What that'll do is that'll break it up for us. That'll break it up for us so that we're going to get the same results. So let's demonstrate that. We have 360 degrees. And we're going to divide that by 6. That obviously turns out to be 60 degrees for each exterior angle. So, what I would like for you to do is, let's take a look at one more. And we'll do this the fast way. There are 1, 2, 3, 4, 5, 6 sides. So, n equals 6. N equals 6 sides. To find the measure of the exterior angle, we're just going to take 360 degrees. And we're going to divide that by 6. And surprise, surprise, we get 60 degrees again. So now it's your turn. I want you to take a look at the following two problems, try and solve it, and once you're done, go ahead and please post your answers to Edmodo. Remember, the first person to reply will start us off. Everyone else will just reply to that thread. That's all for now. Thanks a lot. Bye-bye.